Let me make sure this is the one, yeah. So this is a trick that I guess he used in more than one place but didn't really describe well. So here he has initial condition, u of x comma 1 is equal to 1 plus x. And he has the PDE, y plus u times ux plus y times uy is equal to x minus y. And then you go through the motions. Step 1 is always fine, set up the characteristic equations. And then when you equate 1 and 2, you get something like this after you cross multiply. So you cross multiply, you'll get y dx is equal to y dy plus u dy. If you equate 2 and 3, you'll also get a similar equation. Y du is equal to x dy minus y dy. Then take those two equations that we just came up with and add them straight down. If you add these two equations straight down, what will happen is you can factor out the y in this side and you'll get dx plus du. Actually, I should be pointing here so that you can follow it in the, I can't help myself. So it actually makes a little, like you can actually see a pointer when I do it on the video. So you'll see the dx plus du right here, and then you have an x plus du on this side. Or if we're really taking the derivative of x plus u, right? If you have dx plus du, the process of taking a derivative is linear, which you talked about a lot probably in Dr. Song's class. He just told me that I never see him because his schedule is orthogonal to mine.
That's normal.
Ba-dum-bum. So what you can do is change variables. Let z be x plus u. And then you have an equation now that's separable and solvable. So you get x plus u over y is equal to c1. So what happened in the book, if I go back a few steps, is right at here, he says, just add these two and add these, or something like that. He says, add this equation, the numerators, and add the denominators. Like, you can't do that. I know that I'm teaching pre-calc. I'm pretty sure you can't do that because they do that, and I have to tell them not to do that. So I don't know if it's a language error that he meant to say something else, but this is the steps in between. That was quite a few steps that he's left out. Yeah, I honestly was, because he had written that, I was sitting there for a while going, did I miss something in Calc 3? Because I don't really know that you can do that. But I'm 100% sure you cannot do that. So I'm going to keep the x plus u over y equals c1 up there. In the book now he says, use that to get the rest of it done. But you don't use that to get the rest. And he has another equation all of a sudden appearing. The other equation actually comes from equating 1 and 3, so it gives you one equation, and then equating 2 and 3, it gives you another equation, and then subtracting the two equations from each other. So you'll get x minus y dx minus x minus y dy is equal to u du. So it's a similar trick, except instead of adding the equations, he subtracted them. And then you can do the similar thing that we did in the last go round. You'll get x minus y is dx minus dy, and since the derivative is linear, you can pull the operation of the derivative out, and you now can do a substitution, let z equal x minus y, and then solve.
Is there a benefit to him subtracting it this time?
Well, you need to get that second constant and the u's involved. The other equation, if you remember, had only one. He calls one of them first integral and one of them second integral. Right, you need the two constants.
Oh, right.
So this gives you the second constant. So now we have C2 is f of C1, and C1 is x plus u over y. And we get this. I'm preparing so many classes, I'm writing things down that I probably shouldn't have written down. Good God. At the end, this is what you get. And if you look at his work in this section, he has this problem as an example, I think in chapter 3, and then at the end of chapter 3 he brings that up again. He doesn't have it written in this form as a general solution. He has just the first integral and the second integral. He just stops at the C1 and C2. So I'm putting that into context so you can follow his book from our steps. So then you get this implicit equation, and you have the initial condition, and we did something like this in class. We just took that initial condition, and we plugged it into the equation without solving for u, and you get f of 2x plus 1 is equal to this mess on the bottom. And I'm pretty confident at this time I probably made an error somewhere because there's so many computations. But you get the point. This is, I mean, we did this last time on the in-class assignment. You're just plugging in the piece, the initial condition for u, and then trying to work this down and get this as a function of x only so that you can solve for f and then plug it back into the original equation. So f of 2x plus 1 is this. What do you do now? You let t be 2x plus 1, and then you solve for x, which is 1/2 t minus 1, and then you plug it into this equation, and then you assign it to your students because you've done that before, you've done your time, and it's their turn now, and you want them to learn. I guess you can just stick it on Maple and tell it to solve it. So, and then you're still not done because you have to plug in x plus u over y in for t and solve for u at the end if you want an explicit solution. But you followed, right? Any steps along the way that were confusing?
Seems good if it didn't spell out like this.
Yeah, it's almost worse. I don't know if any of you play guitar, but if you play guitar and get tab off the internet, sometimes that's worse than just earing it because you have enough information to lead you astray. So you spend time kind of wondering why something was written down, and I think that was the issue. And I think I must have spent a good 2 hours wondering why you can add numerators together and add denominators together. But I'm convinced that he didn't mean that. I think it was